Good morning children, welcome to digital lessons. In the last session, we have discussed about classification of elements based on 𝗹𝗻𝗺's law of trade and Newland's law of octaves. Now, today we will study more about the evolution of periodic table. Already we discussed that there were 4 main scientists behind the classification of elements into the form of a periodic table. The first credit goes to 𝗹𝗻𝗺, the second credit goes to Newland's, third one is Mendeleev's. Now, we will study today about Mendeleev's periodic table. He is Dmitry Ivanovich Mendeleev. He is a Russian chemist. He given us a beautiful periodic table. Now, he did several experiments. He arranged the periodic table based on atomic weights of elements. The arrangement of elements he proposed is called Mendeleev's periodic table. When Mendeleev started his work, 63 elements were known. He examined the relationship between atomic masses of the elements and their physical and chemical properties. Now, at the time of Mendeleev, he published only 63 elements in his periodic table in the year 1871, but later on some more elements were discovered. He also given space to accommodate those elements. Out of these 63 elements, he took on a pack of cards, and after each and every chemical reaction, the elements which are similar in physical and chemical properties, he kept on his wall with pins. Now, like this he arranged several atoms, like that he constituted his periodic table. Among the chemical properties, Mendeleev concentrated on the compounds formed by the elements with oxygen and hydrogen. He selected hydrogen and oxygen as they are very reactive and formed compounds with most elements. Now, all his chemical reactions first he did with elements oxygen and hydrogen, because they are chemically very reactive and they are almost reactive with almost all elements at that time. And in order to achieve good results, he also made some experiments with halogens, because halogens are also very reactive apart from this hydrogen and oxygen. Therefore, he used them in his periodic table and did several chemical reactions. Some elements react with oxygen to form compounds with a general formula R2O. Now, these elements he grouped under one category. Let us see what are the elements which are reacting with oxygen to form the compounds of general formula R2O. Now, lithium, it is lithium. Whenever it reacts with atmospheric oxygen, it is forming lithium oxide. Sodium, whenever it reacts with oxygen, it forms sodium oxide. Potassium, whenever it reacts with oxygen, it forms potassium oxide. Therefore, the elements are having valency 2 here, with oxygen is having valency 2. Now, these elements are having the valency 1. Therefore, he kept them under one category in his periodic table, because they are reacting in the same manner with oxygen. Now, next, some elements reacts with oxygen to form compounds with the general formula RO. Now, let us see them. Here beryllium reacting with oxygen to form the compound beryllium oxide. Now, it is the balanced chemical equation. Magnesium reacting with oxygen to form magnesium oxide. Calcium reacting with oxygen to form calcium oxide. Now, here beryllium, magnesium, calcium are having the valency 2. Now, he kept them under one category in his periodic table. Some elements react with hydrogen to form compounds with general formula RH. Again lithium reacts with hydrogen to form lithium hydride. Sodium reacts with hydrogen to form sodium hydride. Potassium reacts with hydrogen to form potassium hydride. Here all the elements which are reacting with hydrogen are having the valency 1, lithium, sodium, potassium. Therefore, they are reacting equally. In earlier case also we have seen that oxygen is also reacting with lithium, sodium, potassium with valency 1. Now, in hydrides also the reaction is same. Here also valency for lithium, sodium, potassium is 1. Therefore, they are reacting similarly with oxygen and hydrogen. Therefore, he grouped them under one category. Some elements react with hydrogen to form compounds with the general formula RH2. Beryllium reacts with hydrogen to form beryllium hydride. Magnesium react with hydrogen to form magnesium hydride. Calcium reacts with hydrogen to form calcium hydride. Now, based on these reactions between hydrogen and oxygen, Mendeleev formulated a law called periodic law. Now, periodic law states that the physical and chemical properties of the elements are the periodic functions of their atomic weights. It means, now all the chemical and physical properties in his periodic table were based on the criteria of atomic weights. Now, he placed in the increasing order of atomic weights along the group as well as the period. Now, let us learn what is group and what is period in Mendeleev periodic table and also silent features of Mendeleev periodic table. This is the periodic table which was given by the Mendeleev in the year 1872. It is the first periodic table, constitutes of 63 elements. Now, here you can observe the groups, the vertical columns are called groups. Now, here also you can see reaction with oxygen and hydrogen. Now, you see first group how it is reacting, forming oxides and hydrides. Second group, their general formula whenever they react with oxygen and hydrogen. Now, horizontal rows are called periods. Now, earlier his periodic table consists of only 63 elements. Later on he modified his periodic table and given as a new periodic table, it will be like this. Now, he modified his periodic table and apart from these 7 groups, apart from these 8 groups, he also constituted another group for noble gases, that is inert gases, that is the last column, and also he has given place for the elements after lanthanum and after actinium. Now, those elements were separately placed under his periodic table. Now, lanthanides are total 14 elements and actinides are also total 14 elements. They were placed at the bottom of the periodic table. It is the modified periodic table by Mendeleev. Now, let us discuss silent features of Mendeleev's periodic table. Mendeleev divided the periodic table into groups and subgroups. It is the first silent feature of Mendeleev periodic table. There are 8 vertical columns in Mendeleev periodic table. They are called groups. They are represented by Roman numerals 1 to 8. Each group is divided into subgroups A and B. Now, let us see how the groups are constituted in Mendeleev periodic table. Now, here you see it is the modified version of Mendeleev periodic table. The 8 vertical columns in Mendeleev periodic table are called groups. Now, it is the first vertical column. Now, you can see here it is a first group in Mendeleev's periodic table. Now, subgroup 1A elements are called alkali metals. Now, how elements are constituted in 1A? Let us see lithium, sodium, potassium, rubidium, cesium. Now, these metals are having same chemical reactions with hydrides, halogens and oxygen. Therefore, they were placed under group 1A elements. They are called alkali metals. Now, let us see, it is group 1A. Now, each group again he divided into A and B. It is second group in Mendeleev periodic table. It is third group, fourth group. Each group is again divided into subdivisions A and B. It is fifth group, it is sixth group, it is seventh group, it is eighth group. Here he placed 8 group under 3 columns. Next, each group is divided into subgroups A and B. Let us see where are the subgroups A and B. Now, here it is the subgroups A and B. Each group 1, 2, 3, 4, 5, 6, 7, 8 are all divided into subgroups A and B. Now, we have seen the groups in Mendeleev periodic table as well as subgroups in Mendeleev periodic table. Now, the second group, now the second silent feature of Mendeleev's periodic table is periods. The horizontal rows in Mendeleev's periodic table are called periods. There are 7 periods in the table which are denoted by Arabic numerals 1 to 7. Now, the horizontal rows in Mendeleev periodic table are called periods. Now, let us see. Now, it is the first period in Mendeleev's periodic table. How these are? The horizontal rows in Mendeleev's periodic table are called periods. It is the first period, it is the second period, third period, fourth period, fifth, sixth, it is the seventh period. Now, children, you might have got a doubt. We left this one and this one at the bottom. What are these? Now, these are nothing but the modified periodic table of Mendeleev, which were later incorporated by Mendeleev. Now, this column is for noble gases and this is bottom columns were for lanthanides and actinides. You see. Now, the 0 group and lanthanide and actinides period were added later in modified Mendeleev's periodic table. Now, these are the place for noble gases. Now, it is the places for lanthanides and actinides. Now, lanthanides, what are lanthanides? What are lanthanides? The elements after lanthanum are called as lanthanides. They are 14 elements. What are actinides? The elements after actinium are called actinides. They are also 14 elements. They are at the bottom, they kept as a separate period in modified Mendeleev's periodic table. Now, Mendeleev predicted that some elements were missing and left blank spaces at the appropriate places in his periodic table. There is some vacancy here. Now, he left the space to further elements which are to be discovered later, and there are also some open places. Let us see, it is also he left for new generation elements which come later on, and also there is an empty place here also in the 7th period. It is a incomplete period. Third silent feature of Mendeleev periodic table is predicting the properties of missing elements. Mendeleev named the predicted elements tentatively by adding the prefix eka. Just now we have seen the third silent feature of Mendeleev's periodic table, that is the predicting the missing elements. That means, he predicted before only some elements, those are yet to be discovered in future, and also on his prediction he given some space for those elements in his periodic table, and he used the Sanskrit term eka, which means 1 before these elements. Now, you see here there is a some space. What is the space? It is under group A, group 3A and group 4A. Now, there were some elements which are called which are having the similar chemical property as that of the elements which are resembling boron in 3A element. That element he called as 𝗂-boron, and also another element which resembling the features of aluminum, he called it as 𝗂-aluminium. There is another element after silicon which is resembling the features of silicon. That means, they are showing the same physical and chemical properties of those elements, and he used the term 𝗂-silicon. Now, let us see what is this 𝗂-boron, 𝗂-aluminium and 𝗂-silicon. Now, children, here we will study the properties of the elements which were discovered by Mendeleev before only. Those elements he called as 𝗂-boron, 𝗂-aluminium, 𝗂-silicon. Now, here we will study the characteristics of them, their color, their density and their chemical reactivity towards oxides and towards hydrides and halogens. Are they similar or not? Now, let us see how Mendeleev predicted the values at that time with the help of a small tabular column. Now, here you see children, the properties are color. Now, 𝗂-aluminium, which was later named as gallium. Now, in the first column we are taking the values which were given by Mendeleev on his prediction. They came true after discovering the element of gallium. Now, see, color of 𝗂-aluminium is blue gray, gallium is also found as blue gray. Atomic mass 68. Now, gallium atomic weight is 69.7. Density of 𝗂-aluminium is 5.9 and gallium is 5.94. Now, formula of oxides. Now, 𝗂 oxide, it is 𝗂-aluminium E2O3, and here it is also forming same composition Ga2O3 gallium oxide. Now, formula with the reaction of chloride, 𝗂-aluminium forming ECl3 and gallium chloride GaCl3. That means, the same what he predicted by Mendeleev before 1872 were resembled in the form of the another element called gallium. He incorporated place by the name of 𝗂-aluminium. This dream came into reality at the time of Mendeleev only. He was survived at that time, and it was the wonder in that generation how Mendeleev predicted the absolute values which came true in the form of element gallium. Next, he predicted the property of 𝗂-silicon. The same were resembled for germanium. The color of 𝗂-silicon is dark gray and color of germanium is also dark gray. Atomic mass of 𝗂-silicon is 68 and germanium is 69.7. Now, density of 𝗂-silicon is 5.5, germanium density also approximately same, almost same, 5.47. Now, the formula with oxides for 𝗂-silicon is ESO2 and for germanium oxide is GeO2. Formula with chlorides, 𝗂-silicon is forming EsCl4 and germanium is forming GeCl4. Now, the chemical reactions are also same. Now, before only Mendeleev predicted these values. Mendeleev predicted the properties of elements 𝗂-boron, 𝗂-aluminium and 𝗂-silicon were almost same as that of scandium, gallium and germanium. Now, in the earlier periodic table, how Mendeleev given space. Now, you see here there is a group, third group. In third group, after boron and aluminum, we are having vacant spaces. Now, after that Mendeleev given space for 𝗂-boron. Now, it is the space for 𝗂-boron. Now, it is the element 𝗂-boron. Later in his modified periodic table, you see it was the place substituted by scandium. That means, eka boron is having the same chemical properties, showing the same chemical properties as that of scandium. He predicted this element before only. Now, eka boron is having same chemical properties and physical properties as that of scandium. After aluminum, he given there was an empty space which was substituted by element gallium in the modified version of Mendeleev periodic table. Let us see, in 3B group there is an empty space. Now, here he incorporated the element eka aluminum. Now, later this element eka aluminum was taken by the element gallium. Now, eka aluminum is having the same chemical and physical properties as that of gallium. Now, he has given this space for eka aluminum which was replaced by gallium. Now, there was an element silicon in 4th A group. Now, he has given a space for eka silicon in his modified periodic table here in the form of germanium. Later on this germanium shows the same chemical characteristics of eka silicon. Now, it was the place given for eka silicon, later replaced with metal germanium. They are having same chemical characteristic as that of eka silicon. Children, do you know what Mendeleev predicted about the metal gallium and what was its melting point? Let us see. If I hold it in my hand, it will melt. The melting point of gallium is 30.2 degree centigrade and our body temperature is 37 degree centigrade. Now, what Mendeleev told about metal gallium and its melting point? If I hold it in my hand, it will melt, because the melting point of gallium is 30.2 degree centigrade, which was less than our room temperature. Therefore, if you hold in your hand, it will melt. Now, it is the element gallium which was melting, because its temperature is very low, its melting point is very low, even less than our body temperature. Now, fourth silent feature of Mendeleev periodic table is correction of atomic weights. Mendeleev's periodic table helped in correcting the atomic masses of some elements like beryllium, indium and gold. Now, children, at the time of Mendeleev, the element indium, gold and beryllium, the atomic weight was accurately unknown. With the help of chemical reactions, by identifying the valency, they used to predict the atomic weight. In the similar way, Mendeleev also predicted the atomic weight of beryllium and corrected its earlier value. Let us see in the form of a small. The formula to find out atomic weight is equivalent weight multiplied by its valency. Before Mendeleev, the atomic weight of beryllium is calculated like this. Equivalent weight of beryllium is calculated as 4.5, it is a constant, and its valency is 3. Now, like that the earlier scientist got its atomic weight as 13.5, which was proved to be wrong by Mendeleev. Now, he corrected valency of beryllium by correcting its valency as 2, and atomic weight of beryllium by Mendeleev's periodic table is equal to its equivalent weight 4.5 into its valency 2. Now, its value is 9. This correction was done by Mendeleev. Now, we discuss the 4 silent features of Mendeleev's periodic table. Now, children, let us discuss the limitations of Mendeleev's periodic table. Limitations of Mendeleev periodic table. Now, in the Mendeleev periodic table, certain elements of highest atomic weights precede those with lower atomic weights. Now, let us see here. Now, here some elements in this group. Elements in the group are tellurium and iodine. Now, tellurium is having the more atomic weight than iodine, but it was placed before in the group. It is the major limitation. Now, let us see. For example, tellurium atomic weight is 127.6, it is preceding the atomic weight of iodine, it is 126.9. Like that, there are two anomalies in the Mendeleev periodic table. Now, it is the place actually given to tellurium, it is iodine, it is not correct according to atomic weights. Next, argon was placed before potassium. Now, where is argon? Here it is the argon, whose atomic weight is 39.9, almost 40. Where is potassium? Here it is the potassium, whose atomic weight is 39.1, almost 39. Now, argon is coming before potassium, it was deviating the law of atomic weights. Now, there is another one. Atomic weight of cobalt is 58.9 and it was placed before nickel, whose atomic weight is 58.6. Now, where is cobalt? Here it is the cobalt, nickel. Now, it is also deviating the his periodic law of atomic weights. Now, elements with dissimilar properties were placed in the same group as subgroup A and subgroup B. Now, let us see here in group 1A. Now, elements like lithium, sodium, potassium were kept under group 1A, and the elements like copper, silver are kept under group 1B. It is also not correct. Now, alkali metals like lithium, sodium, potassium are kept under 1A group, have little resemblance with coinage metals like copper, silver, gold of 1B group. Now, it is the 1B group. Now, by keeping the elements in 1A and 1B, it is not proper. It is 1A group, it is 1B group. The elements are having dissimilar chemical properties. Chemical properties of lithium, sodium and potassium are alike, and chemical properties of copper, silver, gold are, now they are not resembling with each other. It is the major limitation in Mendeleev periodic table. Now, chlorine of 7th A group and manganese of 7th B group. Now, here chlorine is a non-metal, it is a gas, whereas manganese is a metal. Now, where is chlorine? Here it is the chlorine. Now, here it is the chlorine and manganese, top one is chlorine and down it is manganese. They were placed under same group, it is also not correct. Elements having dissimilar chemical property, one is a halogen gas, another one is a non-metal. It is also major limitation in Mendeleev periodic table. There is no fixed position given to the hydrogen in periodic table. Let us see. Now, the chemical reactivity of hydrogen and chlorine are alike. You see, compounds whenever they reacts with hydrogen, compounds whenever react with sodium. Now, halogens are reacting with both hydrogen as well as alkali metal sodium. Now, it is forming hydrochloric acid, it is forming a salt NaCl. Chemical composition is same here, it is forming H2O, it is forming sodium oxide. Now, it is forming H2S, it is forming sodium sulphide. Now, their chemical reactions are alike, like that of hydrogen chemical properties are similar as halogens as well as alkali metals. Now, what Mendeleev did in his periodic table, he has given two spaces for hydrogen. Now, you see, now it is the place in 1A group given for hydrogen. There is also another place given for hydrogen atom in 7th group. It is also a problem, it is a major limitation in Mendeleev periodic table. There is no fixed position accommodated for hydrogen, it is variating between hydrogen 1st A group and 7th A group, and there is no provision for isotopes. Now, in Mendeleev periodic table, there is no provision for isotopes. Children, do you know what are isotopes? Having same atomic number, but different mass number. Now, here their chemical properties are also similar, their atomic weights are different. Therefore, Mendeleev periodic table failed to establish the relationship between isotopes, where they have to be accommodated in his periodic table. These are the major limitations of Mendeleev periodic table. Children, do you know At the time of Mendeleev introduced his periodic table, even electrons were not discovered. Before the discovery of electrons only, he established his periodic table. Even then, his periodic table was able to provide a scientific base for the study of chemistry of elements. Children, do you know there was an element called Mendelevium in our periodic table by the name of Mendelevium. Because of his contribution to the chemistry and periodic table, the atomic number 101 was given for Mendelevium element on the name of Mendeleev. Now, it is the element Mendelevium. Now, Mendeleev was given this honor by predicting first periodic table. We have overcome the difficulties of Mendeleev periodic table. Thank you.